Okay, so for today's lesson, take a look at the problem of the day and pause the video and solve it, like usual. Now 4.3, it's called solve x squared plus bx plus c equals 0 by factoring. So if you remember earlier in the chapter, we did FOIL. FOIL is the opposite of factoring. We're going to take a look at that. First term is monomial. It's an expression that is either a number, variable, or the product of a number and one or more variables. Binomial, the sum of two monomials. Trinomial, the sum of three monomials. So that makes sense. Once we know what a monomial is, binomial and trinomial. Bi is 2, tri is 3. And sometimes we're going to also take a look at the GCF. The GCF stands for the greatest common factor. We'll take a look at all of these terms as we go along here. Trinomial, if you look, x squared plus bx plus c is a trinomial. There's 3 of them. All right, so for the next part, factoring trinomial. So in order to factor the trinomial here, x squared plus bx plus c, we know it would be x plus m times x plus n. You might be wondering, what does that mean? So when we actually factor, we're going to take c, we're going to split it up into factors that give us c when we multiply, but when we add them, we get the b. This will also equal x squared plus m plus n x. So then I'll show you the other part, plus mn. So that's the same as saying c is broken up into m and n, where m times n are these numbers here, that when you add them together, you get n plus n. Okay? All right, so how we factor here. If you remember back, we start off by saying, here's 20. What are my factors of 20? So one set is 5 and 4. That's another set, 2 and 10. And 20 and 1. So you want to look at the way where our factors, that when we multiply, we get 20. So we have 3 options, right? But when we add them, we have to get this number 9. Now, really before we start here, we know it's x squared, so an x goes in each parentheses. If I look here to the sign, so I'm going to go in order. If the sign's plus, that means they're both the same. So 2 of the same signs. What do I have? 2 options. They're either both negative or both positive. I go to this sign to determine it. So I see that it's a negative. Now I need to look at my factors to say, all right, well, all 3 sets of factors multiply to get 20, but which 2, when you add them together, do you get negative 9? Let's think for a second with these 3. It should be 5 and 4. Negative 5 minus 4 is negative 9. And honestly, it doesn't matter which one comes first. That's our answer. All right, so let's take a look at the next one. X squared means there's an x in each parenthesis. I look to my sign. This is different, sorry, D-I-F-F. Different signs, I don't need to look here. Different means, what's my only option for different? One of each sign, right? So one's going to be a positive, one's going to be a negative. And then I think of my factors of 12. Maybe this time around I'll just type them over here so it's not as messy. You have what? 3 and 4, 1 and 12, 2 and 6, right? Well, now because it's different, I add or subtract the 2 numbers and I want to get negative 4. So I'm going to want a positive 2 and a negative 6. So it actually matters this time where you put each of them. 2 minus 6 is negative 4. And remember, if you get stuck, you could always try. Think to yourself, what do you do to take a factor back to a quadratic? You FOIL it. So you could use foiling to check your work. So what I want you to do is pause the video and try the next two, see what you could come up with. Now hopefully, like I said, this is a review of what we've done before, what you've done actually in Algebra 1. So hopefully you're not having too much trouble to get your answer. Now this one is a little tricky because it's not factorable. So you could try all your different combinations, but it's never going to get you the factorable part. Now the next part, we're going to take a look at special patterns of perfect squares. So the first thing is a reminder, what is a perfect square? Perfect squares, you start with like 2 squared, 3 squared, 4 squared. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on. And so on. So we're dealing with perfect squares, and anytime you see a perfect square like here at the end, you should know it's some kind of special pattern. Now, difference of 2 squares, we're going to take a look at the perfect square of 9. Square root of 9 is 3, right? 3 times 3 is 9. So when you have it where there's no middle term or no b, like no x, it's simply this. Take the number, one's a minus, one's a plus. So take a second, try to do letter B with difference of 2 squares. And once again, it doesn't matter actually if the minus comes first or the positive. Here's their answer. Square root of 100 is 10. So it's minus 10 plus 10. The perfect square trinomial, we have that b or that x term as well. And let's look at the perfect squares. Perfect square of 64 is 8, right? So we have x squared. Let's look at it as factoring. Now signs are the same. They're both positive. And when it's a perfect square trinomial, we just take the number they both have in common, which is 8. So really, this is it. Signs are the same. They're both positive. Now really, if you didn't know this was a special pattern with perfect square trinomial, could you factor it? Without, yes. Where does the pattern especially matter? Difference of 2 squares. Don't forget, we could also write this as a square. X plus 8 minus 4. Either answer would be okay. For the next one here, signs are the same. They're both negative. We're going to do an 8. Same thing, the sign is now a negative, right? Is our answer. Now for the next part, the zero product property. If the product of 2 expressions is 0, then one or both expressions equals 0. So now what's the difference in the last slide? Last slide we're still factoring, there's no equal sign. Now we're making it an equation, and we're talking about the zero product property. When they're equal to 0, so it's very important that it's equal to 0, one or both expressions equals 0 to get it to cancel out. What we get for answer are usually 2 roots. It's not always 2 numbers, but most of the time it is for right now. The roots are the solutions of the quadratic equation. So how do we solve something like number 4? For A, they already did the work for you where they got it equal to 0 and they factored. So simply what you do here is set each parenthesis equal to 0. If I subtract 5 from both sides, I get negative 5 and 4, negative 2. And that's actually my answer. So there's an extra step to solving where you have to factor, make sure it's equal to 0, and then set each part equal to 0. Now in B, we have to sort of do it all together. So you might want to pause the video to see what you get. When I factor this expression, are equal to 0. So on the left-hand side, you just have to factor. 9 times 4 is 36. Signs are different. Negative 9 plus 4 is negative 5. My answers are 9, negative 4. And that's it. So let's take a look at another one where you're solving it. Now you'll see here they are not equal to 0. So what I first have to do is actually transpose. I'm going to move this negative 10 over to the left and then factor it. And now, like before, I could factor. Like I say, you might want to pause the video for these. See what you could get. You should get negative 5 or negative 2 for your answer. So remember, before you could factor, it has to be equal to 0. So in this one, I will move the 225 over to the right, just because the x squared is there. It's a little bit easier. Now, you see there's only 2 terms. Actually, the x or the b is gone. And actually, before I do that, you're allowed to switch sides. If you move everything to the left, the 0 to the right, nothing changes. So the difference of 2 squares. My perfect square is 225, which is 15 times 15. So I do x minus 15, x plus 15. My answers are 15 or negative 15. Last one here. You might want to try this one yourself. I'll move everything over again. This is perfect square trinomial. Like I said, you saw, you might want to pause the video. If you use quantity squared, or it's the same, in this case, I could write it x minus 5 twice. You get one solution, though, because they're both equal to the same thing, so you just get x equals 5. All right, so for one last example here. We're doing area. Find the value of x if area equals 36, and x is one side, and x plus 5 is the other side. All right, so length times width equals, so length times width equals area. Right, so it doesn't matter which one's which, but we're going to actually multiply them together, and we're going to distribute and we're going to bring everything over to the left and factor. So it should be plus 9, I wrote the wrong one here, minus 4, because 9 minus 4 is positive 5. Now normally this would be our answer, right? But let's think about one thing here. Have you ever seen a negative area? No. So cross out the negative 9, your final answer is 4. And that's it for the lesson. So your work for tomorrow is this, problem of the day. Do some factoring problems, and then find the solutions, roots or zeros of the equation. And that's it for today.